Welcome to another video about the K-maps. Now we're gonna go on with those maps. And once again, we're just gonna pretend that we skip the truth table and that we already have the K-map. So let's actually make our K-map uncounting gray code. So we have 0, 0, 0, 1, 1, 1, 1, 0, 0, 0, 0, 1, 1, 1, 1, 0, and here 0, 0, 0, 1, 1, 1, 1, 0. And our entries are actually 0, 0, 0, 1, 0. Well, let me just, before I make the entry and insert the entry, let me just make the structure for the map. Otherwise, it's gonna be messy, I think. That is gonna be more precise if I do that, but I hope it's not gonna be totally screwed up. So. And like this. And here we're gonna have E. Okay. Again. Like this. And lastly, like this. Okay, so our entries are going to be 0, 0, 0, 1, 0, 0, 0, 1 again. 1, 1, 0, 0, 0, 0, 0, 1, 0, 0, 1, 1, 0, 0, 0, 0, 0, 1, 1, 0, and 0, 0, 0, 1. Here we have 1 and here we have 0. So our entries are AB, CD, and here we have E. Now, once again, we're going to use the minter representation. So we're basically going to be interested in where in the maps we have 1. So our prime implicants are going to be the ones that are inside the map, and we want to make them as a power of 2, which by basically making groups as large as possible. So our first group is going to be a group of 2 with those 2. Our second group is going to be another group of 2 made by those 2. Another group is going to be a group of 2 made by those, and a group of 2 made by those, and yet another group of 2 made by those 2. So this is not a group of 1 each, but it's a group of 2 because those 2 talk to each other. So again, we can think about this as a cube which has this plane and this plane at the bottom and this plane at the top. So I like to think about it like this, and I hope I'm not gonna screw the drawing too much, even though I'm not really bad at drawing, to be fair. Yeah, and you can easily see it. Okay, so it's essentially a cube, and we basically have this plane here. So those one are at the bottom, and there are those. We have a group of 2 here, and then we have a group of 2 here. So since it's like this, a group of 2 basically here. And we have like this, so a group of 1 here. A group of 2 here, connected from here to here, so top and bottom, like so. Now, we still have the top plane with this group here at the top, which essentially is a group of 2 with those 2, those 2, and a group of 2 again here, essentially in the middle, which is basically a group of 2 here. All right, so this is basically our map, and since we are using the mean term representation, we're going to have a sum of product, and we're basically interested in where the values are 1. So our groups are made of prime implicants of 1. And we're interested in where A, B, C, D, and E are asserted. So where they are 1. So A is 1 here. A is 1 here because A. So 1, 1, 1, 1. B is here in the middle. Like so. C is here in those 2, and D is here in those 2. Lastly, we have E, which is 1 only on the top plane. So E is 1 only here. Now, once we're done that, we're basically going to write the expression for each and every group. So our expression is going to be the following one. Let's start with this group of 2. So it's actually falling completely inside A, so we have A times. It's completely outside of B, so we have B naught. It's completely outside of C, so we have C naught. It's half inside and half outside of D, so we're going to leave D alone. And it's completely outside of E because it's on the bottom plane. So E naught. We're now going to move to the other group, which is this one. So this group here, it's completely inside A, so we have A. It's half inside and half outside B, so we're going to leave B alone. It's completely outside of C, so we're going to have C naught. And it's completely outside of D, so we're going to have D naught. Lastly, it's completely inside of E, so because it's in the top plane, so we're going to have E. Now we're going to move to this group here. This group here is actually completely outside of A, so we're going to have A naught times It's half inside and half outside of B, so we're going to leave B alone. It's completely inside of C, so we're going to have C. And it's also completely inside of D, so we're going to have D. Lastly, it's completely outside of E, so we're going to have E naught. Now we're going to move to the other group, which is this group here. It's half inside and half outside of A, so we're going to leave A alone. It's completely inside of B, so we're going to have B. It's completely inside of C, so we're going to have C. And it's completely inside of D, so we're going to have D. Lastly, it's completely inside of E because it's in the top layer, in the top plane, so we're going to have E. Lastly, we're going to have this group of two, one on the bottom and one on the top. So bottom and top, those two. They are actually both inside of A, so we're going to have A times. They're both outside of B, so we're going to have B complement or B naught. They're both inside of C, so we're going to have C. And they're both outside of D, so we're going to have D naught. Lastly, we cannot say anything for E because it's one on the bottom, one on the top. So it's it's both inside and outside of E. So we're gonna leave E alone. And this one is our final expression. So for these particular Karnaugh maps. So stay tuned for yet another video about K-maps. Cheers and bye for now.